Kia ora koutou, welcome to this final video of Chemistry 2.4 Structure and Bonding. In this video we're going to be looking at energy change calculations using amounts. So in the last video we looked at how we could calculate the change in enthalpy of a reaction using bond enthalpies. This time the questions are slightly different. So I thought the best way to go over it would be to just go over a past exam question. So last year one of the questions was when magnesium is burned it produces a white powder according to the equation below. So magnesium plus oxygen goes into magnesium oxide, and the change in enthalpy of the reaction is negative 1,203 kilojoules per mole. In other words, 1,203 kilojoules per mole is released. So it says calculate the mass of oxygen required to produce 1,804.5 kilojoules of energy. So in here we've said we're producing that, but that's effectively going to be a negative number because it's an exothermic reaction. So what we need to do is calculate how many moles of oxygen we need in order to release that amount. So if 1 mole of oxygen gas releases this much, how many mole of oxygen gas releases this much? So we can just go the amount of O2 required is, and then there's no real formula for this. We kind of just need to work out that we just have to go 1,804.5 and divide that by 1203. I'm just using positive values here because if we're talking about the energy being released, then they're both positive values. So we've got that amount, and that actually equals 2.5. No, sorry, 1.5. So it's nice and easy. 1.5. So 1.5 mole of oxygen gas is required to release this much energy. So then the question is calculate the mass of oxygen required. So if we've got the amount equals the mass divided by the molar mass, what we're trying to work out is the mass here. So we need to rearrange this equation to be the mass equals the amount times the molar mass. So the molar mass of O2 is, because we've got 2 oxygen atoms, we need the mass number of oxygen times 2, so it's going to be 16 because there's 2 oxygen atoms times 2 equals 32. So now that we've got the molar mass, we know the amount is 1.5, so I'm just going to bring this all over here. The mass equals the amount, which is 1.5, times the molar mass, which is 32, and we end up with 48 grams. So we would need 48 grams of oxygen to release 1,804.5 kilojoules of energy. Okay, so the next question in the last year's exam, calculate the energy change when 100 grams of magnesium oxide is produced. So what we'll do is, I might actually just bring this down so that we can see the formula. Okay, so yes, the energy change when 100 grams of magnesium oxide is produced. So the way that we go about this is kind of 3 steps. The first step is that we need to calculate the amount of energy that's released by 1 mole of the substance that we're talking about. So calculate the amount of energy released by 1 mole of the substance. So here we can see that 2 moles of magnesium oxide being produced releases 1,203 kilojoules per mole. So we need to divide that by 2. So 1 mole releases, I'm just going to put equals negative 1,203 divided by 2. So we should end up with 601.5. The next step is that we need to calculate the amount of the substance that we actually have. So we've got 100 grams there. So we'll calculate N. I'll just write in that step. So step 2, calculate N. So if we've got 100, so the amount equals the mass divided by the molar mass. So that equals the amount we've got is 100 grams. We're going to divide that by the molar mass, which they've given it to us in the full form there, magnesium oxide. So we're going to go 40.3, and that equals 100 divided by 40.3, 2.48. And so the general rule of thumb with chemistry is that we just go to three significant figures, so 2.48 mole. And then the third step in our calculation is that we multiply step 1 by step 2. So we're just going to go so if 1 mole releases 601.5 kilojoules, then 2.48, to work out the amount of energy released by 2.48 mole, we just multiply them together. So 601.5 times 2.48, 601.5, it should equal 1,492. 1492.5, or even 0.6, and we'll just round that to three significant figures, so 1,490 kilojoules. Calculate the energy change, kilojoules, and we can say 1,490 kilojoules, and what's good form is that if we define that it's 1,490 kilojoules released, or of heat. So heat released when we've got 1,000 grams of that magnesium oxide. So if you got both of those questions right in this exam, that would have been an excellent answer. So thanks very much for watching the series. It's a lot of videos in this playlist to get through this Chemistry 2.4 standard. So well done if you've got through this far. All the best for your exam for the Chemistry 2.4. Like and subscribe for more Level 2 chemistry videos. I'll see you next time.